Week 7, Lesson 4. Okay, so up at the top of the screen, you are seeing two formulas that look really similar, but I'm going to use a highlighter. I'm going to highlight the top one in green, right? And I'm going to highlight the bottom one in blue. Okay, and I want you, when you're doing this lesson, to make sure that you're looking at the correct formula. Okay, so like if you're looking at this first problem where it says expand this up to the term in x cubed, right now that doesn't look like either the green or the blue. But if I rewrite it as 1 plus 2x to the 1/2, it looks like the one in blue, right? Because the exponent is a fraction and I can write the stuff that's inside, right? So when I'm trying to plug into the formula, every place that I see an alpha symbol, I'm going to write a 1/2 because that's what this exponent is. And every place in the formula that I see an x, I'm going to write 2x. Okay, now I know that looks weird, right? Those aren't actual equations. But now all I have to do, let me kind of scoot this up a little. I just need to make sure that I am filling into this formula, right, with these values. So here we go. Okay, so I'm going to be using the formula right up here. I'm going to be plugging in 1/2 for all the alphas and 2x for all the x's. So starting right here, we start with a 1. Then we have alpha x, which in this case is going to be 1/2 times 2x, plus, now here I've got alpha, which is 1/2, times alpha minus 1, which is negative 1/2, times x squared, which is going to be 2x squared, all over 2 factorial, which is just 2. I'm going to go ahead and just simplify that to be 2. Plus, okay, so I'm on the third term now. I've got alpha, which is 1/2, times alpha minus 1, which is negative 1/2, times alpha minus 2, which is negative 3/2, times x, which in our case is 2x cubed, all over 3 factorial. Okay, so now this, if I simplify it, becomes 1. This, if I simplify, becomes x. This, and again, you may have to put this all into your calculator. You should get, actually that's not a plus. Let me get rid of that. It's a minus 1/2 x squared. And the last one should be positive 1/2 x cubed. Okay, so now the next example, if I rewrite this, it's going to look like this. 2 times 1 minus 3x to the negative 1, right? That's how I can move this up. And it looks like this formula up top because I have, right here, I have a negative exponent and I have 1 minus something. Okay, and notice also this has a minus in there, whereas this one has a plus. You got to be really careful. One misplaced negative and it all just goes awful. All right, so let me write down what I have. I have, for this one, my n value is going to be 1, and the x that I'm going to be using is 3x. Okay, so don't forget there's a 2 out in front. So I've got 2 times, and then this is where I start plugging into the formula. Okay, you've got it in front of you that you can see. I know that I can't see it on the screen, but I do have it on paper in front of me. So I'm going to have 1 plus, and then I multiply those 2 together. That's 3x plus, and then I've got n times n plus 1 over 2 factorial times 3x squared. And then my third term is going to be 1 times 2 times 3, right? Because I keep adding 1 over 3 factorial times 3x cubed. Okay, so I think I'm going to simplify the stuff that's inside the brackets first. 1 plus 3x, And again, there's no shame in using a calculator. I believe here you get 9x squared. And here this becomes 27x cubed. And then lastly, when you finally distribute, your whole answer here should be 2 plus 6x plus 18x squared plus 54x cubed. Okay, again, the formulas, all right, and aren't you happy this is open notes for you guys? Last year, they didn't get open notes on this stuff. Okay, so for this one, it's saying, let's use binomial expansion to show that this equals this. And notice with the dot, dot, dots here, that it does kind of keep going. We're only going to expand it out as far as we need to. Okay, so let me rewrite this as, let's see, I'm going to write it as 1 plus x to the 1/2 and 1 minus x to the 1/2, which ends up being on the top, I'm going to use a highlighter. On the top over here is 1 plus x to the 1/2, and I'll expand that out. And then the one on the bottom, this is going to be 1 minus x to the negative 1/2, right? Because I have to move it up in order to use the formula. It can't be in the denominator. Okay, so let me expand the top one, the one in blue. Again, trying to color code this. And the one in blue, my alpha is going to be 1/2, and my x is going to just be x. Okay, versus down below, here my alpha is negative 1/2, and my x is negative x. All right, again, if you're looking at the formula, right, it's a 1 plus x, which is making this look kind of strange. Okay, so let me expand the top one in blue using the formula. It's 1 plus the two things multiplied together plus the alpha times alpha minus 1 over 2 factorial x squared. And if I simplify that, right, that's an arrow in case you can't tell what I'm drawing, it's an arrow. Simplifying that, I get 1 plus 1/2 x minus x squared over 8. Okay, now the one in pink, all right, it's the same formula, right? Still the same formula, and I have 1 plus, and then I have to multiply these two things together, negative 1/2 times negative x plus alpha times alpha minus 1. Oh, I also forgot the 2 factorial. And this one has 3 factorial. Again, an arrow. And if I simplify all that, right, those 3 terms, I get 1 plus 1/2 x plus 3/8 x squared. Okay, now keep in mind, I moved this up. So I end up with a binomial times a binomial. In fact, let me move it up so you can actually see it. Can I erase some stuff? Let's see. Let me try. So what I have here is 1 minus x to the negative 1/2. So you've multiplied binomials together. I need to multiply this times this. In other words, I am multiplying, and let me highlight it for you, this times this. Now, maybe you're really, really good at distributing. Personally, I tend to make a lot of mistakes when I try to do that, so I like to multiply polynomials together by using a box. So it's going to look something like this. 1 plus 1/2 x minus 1/8 x squared across the top of a box. And then the pink one along the side is 1 plus 1/2 x plus 3/8 x squared. Right? And again, if you're looking at the top of the page, you know that I only have to get to the x squared term. So I don't even need to fill in this entire box. I can just sort of start filling this in and multiply the row times the column. So this is 1/2 x, negative 1/8 x squared. This is 1/2 x and 3/8 x squared. Multiplying by 1 is always so nice. This becomes 1/4 x squared, which means it's also sort of incognito as 2/8 x squared. But look, when you actually go along the diagonals, this does equal 1 plus x. Let's see, 3/8 plus 2/8 is 5/8, minus 1/8 is 4/8, or look at that, 1/2 x squared. And if I filled the rest of these in, I would get more of this, but this is all that it asked for.